Hello, geometry class. I did not want to leave you high and dry because I know you would probably revolt if you did not have a lesson of geometry to do today. So I have the lesson all ready for you. So we are doing section 6.5, conditions for rhombuses, rectangles, and squares. So before we even start there, let's just be clear about what makes something a rhombus, a rectangle, or a square. So what makes something a rhombus? Good, I heard you all loud and clear. 4 equal sides. That's it. The sides are equal. It says nothing about the angles. Rectangles, what makes something a rectangle? 4 right angles. Doesn't say anything about the sides. And you should be taking notes. And square has 2 criteria. It puts both of those together. It has 4 equal sides and 4 right angles. So what we're going to talk about today is that you can actually figure out whether a parallelogram, which we've talked about before, has 2 pair of parallel sides. Looks like I spelled it wrong, but I didn't. There it is. But you can determine whether a parallelogram is a rhombus, a rectangle, and or a square by looking at its diagonals. So when we look at all these, I want you to notice that for all 3 theorems that are on this page, here's just the first one, we are talking indeed every time about a parallelogram. So that's part of our given. It's a parallelogram. And then the extra piece of information is about the diagonals. So in this case, you notice they don't say diagonals right here, but AC and BD are your diagonals. And what do they say about them? Right here, perpendicular. So if that is the case, okay, you have a parallelogram and the diagonals are perpendicular, they meet at 90 degrees, then this figure has to be a rhombus. Okay, so it could be a situation, well anyway, I'm not even going to try to make it up. You know how it goes south when I try to make up my own problems. So we'll just stick to the plan here. Okay, so that's the first one. The second one, slide this up here. I'll put all 3 on there at once. Oh my goodness, quit moving. Now I got the timer in the middle of the picture. Oh well. So again, we're talking about a parallelogram. But in this situation, they don't talk about the diagonals being perpendicular. What do they say? A pair, one diagonal. They're only referencing a one diagonal. Bisects. What does bisect mean? To cut in half. A pair of opposite angles. So they're taking 1. So there's your one diagonal. And it is bisecting this whole angle, meaning 1 and 2 are equal. And 3 and 4 are equal because it bisected this angle, this big angle, and it bisected this big angle. Could it happen going this way too, where it split them into 2 of the same and 2 of the same? But it doesn't have to do both. You don't have to have both. You just need one of those diagonals. So again, if you have the parallelogram and one diagonal cutting them, that also means you have a rhombus. So I would circle, some of the things I'm pointing out here. This one is plural, diagonals, both of them. All right, when we go down here, again, same thing. It's a parallelogram. But now it talks about both diagonals. Again, going back to both of them. And it says they are congruent. So when you look at this, I'm just trying to slide this up a little better. When you look at this diagonal, BD and AC, if they're the same, so again, you have a parallelogram, and the diagonals are the same length, it's a rectangle. So my question is, how would you know if something then was a square? I mean, none of these, and this is the only 3, we don't have like 14 of them today like we did a couple days ago. How do we know none of these say that you'll get a square? This one says you'll get a rhombus, this one says you'll get a rhombus, and this one says you get a rectangle, but yet look at, our title was Conditions for Rhombuses, Rectangles, and Squares. Well, we've done rhombuses, we've done 4 sides. Those are the first 2. And we've done rectangles. That's the one down here. So squares means both. So what would that mean? How would you put these theorems together? It means you'd have to have the what? You need a parallelogram with diagonals congruent and one of these other situations. If you were just looking at diagonals, you know, if you knew the sides, of course, and you knew they are all 90-degree angles, you got a square. That's probably the definition. But there's other ways to determine that you have a square too. So either the one diagonal is bisecting opposite angles, or what was the other option up here? The diagonals are perpendicular. So if one of those 2 happens and the diagonals are congruent, you would then have a square because you have now completed both things. A rectangle and a rhombus together give you a square. All right, so we're going to move down to example 1. I'm just leaving this up here in case you're hopefully writing it down. It says a parallelogram has angle measures of 20, 160, 20, 160. Well, first, so let's just do some checks here and reinforce some information. Do they add up to what? What should all 4 of these add up to for a parallelogram? 360, yep. And they do, because that's 180 and that's 180, and you'll get 360. Also, we learned that a parallelogram, the ones consecutive next to each other, should be supplementary. Are they? Yeah, because I listed them in order. So if we have, actually I'll draw that a little bigger. 120, obviously the obtuse angle is the 120. And that's 120 and 160. Okay, good. So the consecutive angles are all 180. And that is something you also learned. 6, 2, or 3. And opposite angles are also the same. Okay, so clearly a parallelogram. They tell you that, but let's see all the things we know. Now, can you conclude that it's a rhombus, a rectangle, or a square? Okay, well, let's check. We know we have a parallelogram, so we can use these up here, okay, to check. Do we know that the diagonals are perpendicular? No. Do we know that the one diagonal bisects the other? No. Do we know that the diagonals are, no, we don't even have diagonals. So we can't go by that. We could look and see, oh, do we know that the sides are all the same? If they were, it would be a rhombus. No, we don't know. Do we know that angles are all 90? No, we know it's not a rectangle. That's for darn sure. It's not a rectangle. Not 90 degrees. Could it be a rhombus? It's not going to be a square because we don't have the 90 degrees. Could it be a rhombus? It could be. It doesn't mean it is, but it could be a rhombus. We just don't know enough information to be able to confirm that. Because if you move these closer, it could look just like sideways. I am just so bad at trying to draw them equal. Something like that, where it's 120, 60, 120, and 60, where the sides would all be the same, just not the angles. Okay? All right, let's look at this bottom one. Suppose the diagonals of a quadrilateral, how many sides does that have, class? 4 sides. Okay, bisect, what does that mean? Cut them in half. Okay, so the diagonals of a quadrilateral bisect each other. Ooh, well, we have a whole bunch of theorems that talk about diagonals now, so we can go look. Can you conclude that it's a rhombus, a rectangle, or a square? I want you to think about that for a second and see if you have a guess. My first question, hopefully you all decided a guess, is do any of the theorems here talk about diagonals bisecting each other? No. 90 bisects the angles, right? Doesn't say it bisects each other. That's what this says. So the diagonals bisect each other. That means this. Okay, we're not talking angles here. And it says in this one that they're congruent. That doesn't say that either. So I do recall that we did talk about this though. Does anybody remember when we talked about the diagonals bisecting each other? Kind of figure it's on a parallelogram. Every parallelogram has diagonals that bisect each other. Okay, so this basically you can say this is a parallelogram. You cannot say if it's a rhombus, a rectangle, or a square. Could be. Don't know. All we know for sure is that it is a parallelogram. All right. One more on the back. For what value of y is it a rectangle? Okay, so they do say it's parallelogram right here. So these are all, oops, sorry, not this. I'm sorry. What am I doing, people? Whiteout to the rescue. One moment, please. Come on, Whiteout. It's a brand new one. Oh, man. Just put this in there. It's already not working. That is not fair. I just bought this for $3.97 yesterday. That was out. Oh, there we go. There we go. All right. I know it's parallelogram. So they're trying to say, okay, how could we figure what value makes this a rectangle? Well, let's go back and look at this rectangle, because I remember this one here that talked about it being a rectangle. And it said if these were the same. So that would mean that DF is congruent to EG. This is congruent to this all the way across. So you might be thinking, okay, that's fine, but this is only this little part, and this is only this little part. But what did we just say about parallelograms on the bottom of the last page? Diagonals bisect each other. So we know this and this are the same. And if it's a rectangle and we know that these are the same, these will all four have to be the same. So putting those two pieces of information together, that the diagonals are congruent and the diagonals bisect each other. Those two pieces of information together tell us that we can set these equal to each other. So 5y plus 3, I think it says, I can't read it over my writing, equals 7y minus 5. So go ahead and solve that. Let's wait a second here. Shoot, I wasn't going to show you. Okay, so did you get an answer? 4 is correct. If you had 4, here's the work for it. Okay, just solve for y. So take a look if you didn't get 4 for some reason. There's the work. And now you have the rest of the time in class to work on your homework. So I'll leave it up to the sub to determine if you guys can work together or not. If you are working together though and you aren't working on math, I'm going to ask her to separate you. So please stick to the homework. All right, take care. Bye.